going to go over linear models and applications. Pretty much you can expect anytime we say models or applications, we're not talking about math, we're talking about word problems. Many real-life situations can be modeled by linear equations. It's important for us to study this type of relationship not only to be prepared as a member of the workforce, but also to help us understand comparisons we read in media outlets. This particular article shows that overall the U.S. produced 25% of the world's GDP in 2019 with only 4.3% of the world's population. So immediately you see a couple numbers being thrown out there where they're tying this to mathematics. Another article I found that I thought was really interesting was the cost to charge an electric vehicle, because we all know gas is expensive. So the thought is if we get an electric vehicle, it'll be cheaper, but you still have to charge it. So this article shows you how to estimate how much you're going to pay in electricity to charge your EV. To get a rough estimate of your own charging costs, you multiply an EV's kilowatt-hour miles rate by your electricity rate, which you can find on your monthly bill, which gives you an electricity cost per 100 miles driven. And again, you start seeing where math becomes important when you're trying to figure out how much you're going to pay for something, right? There are hidden costs sometimes that we really want to investigate. We're going to break this down and talk about some simple linear equations to start, and then we'll grow it and make it a little bit bigger. Of course, I'm trying to model things that I think you're going to see in your homework, so sometimes the problems seem a little silly and not as real world as I would like them to be, but I also know the kind of assessment that are available, so we want to make sure we do both. So we're going to start with the building has a square base, the perimeter is 800 feet, what is the length of each side of the building, and then let's find the area of the building. So it's really important here that it says it has a square base. So I know all the sides are the same. So let's call them all x. So there are 4 sides, which says that 4x is equal to 800. I'm going to divide by 4, and that says x is equal to 200. And let's go ahead and put on that that is feet. So now we know the length of each side. We want to find the area. So the area of a square is x squared. So our area will be 200 squared, which gives me 40,000. Now I want to make sure I put the dimensions. This is 40,000 square feet. The second one says the height of the Strat is 165 feet higher than the Eiffel Tower. And the Strat, if you don't know, is a big hotel in Las Vegas. So this says, if the combined height of the Strat and the Eiffel Tower is 2,133 feet, find the height of each building. So I have 2 buildings. I have the Strat and I have the Eiffel Tower. What I tend to look at is which one looks shorter. So it says the height of the Strat is 165 feet higher than the Eiffel Tower. So I'm going to let the Eiffel Tower be x, and that way the Strat can be x plus 165. Then together they have a combined height of 2,133 feet. So I'm going to add x plus 165. Plus x, and that's going to be 2,133. On the left, I can combine the 2 x's, so I have 2x plus 165 is 2,133, so I'll subtract the 165. Now I know 2x is 1,968 feet, so I'm going to divide by 2, which says x is 984. Now 984, x is the Eiffel Tower. So the Eiffel Tower is 984 feet. And then the Strat is going to be 165 feet taller than that, which is a total of 1,149 feet tall. All right, next one says a restaurant has 52 employees. There are 18 more part-time employees than full-time employees. We're going to find the number of full-time and part-time employees. So just like last time, I want to say, well, what are the 2 things I have? I have part-time employees, I have full-time employees, and I like to start with which one has less. So it says there are 18 more part-time than full-time, so full-time there are less. Let's make that x is full-time, and then part-time is going to be x plus 18. Together, we have 52, so x plus 18 plus x is 52. Just like the one about the Eiffel Tower and the Strat, I combine the like terms. So I have 2x plus 18 is 52. I subtract 18. That says 2x is equal to 34. So when I divide by 2, I get x is 17. So 17 is my full-time workers. And then part-time, I have to add 17 and 18, which gives me 35. There is that nice part that you can check 17 and 35 that adds up to 52. So you go like, it looks like I did it right? You always want to look back and think, does this answer make sense? Things that wouldn't make sense is you can't have a part of an employee. So if I got a fraction here, I would think I did something wrong. If I got a negative, I would say it looks like I did something wrong. So you want to just think it through and think, is this a reasonable answer to get? The next one says, a building has a rectangular base. The length of the building is 30 feet less than twice the width. If the perimeter of the building is 390 feet, find the dimensions of the building, then find the area of the building. So this time we have a rectangle. A rectangle has a length and a width. In this particular rectangle, it says the length is 30 feet less than twice the width. So I have twice the width minus 30. It's really important that you're always thinking there are 4 sides. So if you need to write them all down, then I would encourage you to write them all down. When I add them all up, I'm supposed to get 390 feet. So we have 2 times the width plus 2 times the length, which is equal to 2w minus 30, and that's supposed to be 390. So let's keep our 2w. Let's distribute this 2, so 2 times 2w is 4w. 2 times negative 30 is negative 60, that's 390. So the 2w and the 4w make 6w. Minus 60 is 390. So I'm going to add the 60 over, so now 6w is equal to 450. Divide by 6, divide by 6. This says w is equal to 75. We want to say that's feet. Our length is going to be 2 times 75 minus 30. So that's 150 minus 30 is 120. Also in feet. So we have our dimensions. This is a 75 by 120 foot building. Now we want to have the area. So the area is going to be the length, 120, times the width, 75, which gives me 9,000 square feet. And the next one, we are going to find the volume of a cylinder. So the volume of a cylinder with a height h and a radius r can be found using the equation v equals pi r squared h. We are going to find the volume of a cylinder with a radius of 2.5 inches and a height of 3.8 inches. So anytime you get to things that have circles, make sure that you have the radius instead of the diameter. If you get the diameter, you're just going to divide by 2. But if you already have the radius, then you're ready to get started. So we're going to write down that v is equal to pi. Our r is 2.5. It will be squared. And then I have the h, which is 3.8. I will talk about the units as we go. We could put them in the formula. It just takes up more space, so I usually drop them and think about it at the end. So I'm just going to do the number part first. I'm going to do 2.5 squared times 3.8. And this gives me that the volume is 23.75 pi. And I'm going to write in that this is inches cubed. So the cube comes from, I had 2.5 squared, and then I had 3.8 inches. So if you have inches squared times inches, that becomes inches cubed. And volume is always cubed. It has a length, a width, and a height. That's 3 dimensions, so it's cubic. Now, pay attention to how you put this in any kind of answer, and you want to read what it says. So if it says give the exact answer, this is the exact answer. I didn't use the pi button in my calculator to figure out an approximation. So this would be exactly the volume of the cylinder. If it allows you to give an estimate, then do not multiply by 3.14 unless it specifically says that. What you want to multiply by is the pi button in your calculator. So when I multiply this by pi, I get 74, let's do 3 decimal places, 0.613. Again, this is inches cubed. Let me show you why I say don't just multiply by 3.14. So if I take this 23.75 that we just found, and I multiply by pi, and one way you can do it, like if you're using Desmos, is just type the word pi, P-I, and it goes ahead and it multiplies. Of course, you could just type in 23.75, and when you look on your keypad, you can see at the bottom, there's a pi there, and that will give you the same result. What this is not the same as is if I do 23.75 times 3.14. Do you see how my number is smaller? When we use 3.14, we're using an estimation for pi, and it's always going to come in under what it's supposed to be. And you can see, like, it's a little bit off. The bigger the number you're multiplying by, the more off it's going to be. So that's why you'll find that we like to use the word exact, is so that we do the approximation at the very last step. So you can think if you're building something or doing any kind of construction, you do want to be as exact as you can. Let's talk about some other good application, which is the distance formula. So this starts as the distance from Indianapolis to Chicago is 183 miles. If your average driving speed is 61 miles per hour, how long will your trip take? So we're going to use the formula D equals RT. D is distance, R is rate, T is time. So let's just put our numbers into this formula. So D is equal to RT. Our distance is 183. Our rate is 61 miles per hour, and our time is unknown. I'm going to take the 183, I'm going to divide by 61, and that's going to solve for time. This says it's going to take us 3 hours to make this trip. So let's try another one. This says Ellie and Gustavo are 64 miles apart and riding their bikes on the same trail toward each other. Ellie is cycling 3 times as fast as Gustavo. If they meet 2 hours later, find the speed of each cyclist. So in this one, we are again using the formula D equals RT. We have a distance, we have a rate, we have a time. We need to think about what Ellie and Gustavo have in common on their rides, and that element would be time. We're going to let R be the rate of Gustavo because remember how we were talking about earlier, I kind of picked the smaller thing as my variable. So I'm going to let R be the rate Gustavo's going because Ellie's going 3 times as fast, so her rate's going to be 3R. Now we want to think together. They biked a total of 64 miles. So when I think about this D equals RT for the 2 bicyclists, I want to say, well, if I look at Gustavo, he went his rate for 2 hours because they both went the same amount of time. Plus, when I look at Ellie, who went 3R for also the 2 hours, together that should add up to 64. So however far Gustavo went with however far Ellie went, together it's 64. So this says 2R plus 6R is equal to 64. So 8R is 64. When I divide by 8, this says that Gustavo's going 8 miles per hour. Now let's go back and read the problem because I do think that's an important part of doing word problems. You read it, you figure out what do I know, what do I need to know, how they're connected, and then go back and say, well, what did you really even ask me for? So when we go back, it says, find the speed of each cyclist. So we found out that Gustavo's going 8 miles per hour, then that means that Ellie is going 3 times 8, which is 24 miles per hour. And let's just write Gustavo here so we are clear about what happened. So here's our last one. After robbing a bank, a robber gallops off at 14 miles an hour. 30 minutes later, the town sheriff leaves to catch the robber at 15 miles an hour. How long in minutes after the sheriff takes off does it take the sheriff to catch up with the robber? All right, so here we go. One more time with this formula that distance is equal to rate times time. Now, last time when we were talking about the bicyclists, they were both going the same amount of time, and this time they're not going the same amount of time. The robber goes off first, and the sheriff comes out later. But what happens? What do they have in common? The distance. So the distance for the robber has to be equal to the distance for the sheriff in order for the sheriff to catch the robber. So this time we know the rates, right? So when I look at the robber, I know the rate is 14 miles per hour. And let's just call T the time. The trickiest part of this problem is this next step, where I'm looking at the sheriff, and I know the sheriff goes 15 miles per hour, but he left 30 minutes later. Now, there's this little problem that this time was stated in minutes, and the rate was stated in hours, and you always want them to be the same. So what I'm going to say here is 30 minutes divided by 60 minutes an hour means this is half an hour. So you can write 1/2 or you can do 0.5. So what I want to say for the time here, it's time minus, let's do 0.5. I think that'll be easier. So make sure you have that agreement between the rate and the time. They need to be in the same unit. So now 14t is equal to 15t minus 0.5. So I have 14t, that's fine. Distribute the 15. I get 15t minus 7.5. If I bring the 15t over, I get negative t is equal to negative 7.5. So I want to change that to a positive. So now I have t is 7.5. So just like the last one, I want to go back and review what was the question? What am I trying to answer? So the question says, how long in minutes after the sheriff takes off does the sheriff catch up to the robber? So what we solved right here was the time in hours. So if we want the time in minutes, we're going to have to do 7.5 hours times there are 60 minutes in 1 hour. So we're just multiplying by 60, which says the time is equal to 450 minutes, a long ride. So that's the end of our little lesson today. What I tell you about word problems is write everything down, label things, think about what do I know, what's the connection between what I'm looking for, and then always reread the problem to make sure you've answered it correctly. Good luck.